Myself, Narender, Assistant Professor of Department of Mathematics in B.V. Raju Institute of Technology. Now I am dealing with the course of linear algebra and calculus. In this case, we are dealing with the 15th unit as in higher order of differential equations. Now, already we discussed that what is the definition of higher order differential equation, then what is a complementary function, that is called the general solution of the differential equation of homogeneous. Now we are dealing that non-homogeneous terms, that is called the particular integral, that is in the case of special cases. Now, before writing that equation, the equation f of d of y equal to q of x. So what are the special cases? The special cases are, one is the q of x will be equal to e power ax, and the second one is sin ax or cos ax, or, and one more function x power m is a positive integer here, Now the next case, the combination of the above functions, that is e power x into v of x. The last one, x power m into v of x, where the v of x is a sine or cos x. Here the v of x will be again sine ax or cos ax. Let us consider that the v of x may be e power x, then it moved to the fourth method again. So that is it. If the given this right hand side function is not given, not of this following 5, then how we are going to solve the problem? That is a generalized method. Before going to the generalized method, we write that what is the operator of 1 by d. It is called the integration. It is an inverse operator, we call inverse operator. So based on this operator, we'll solve some problem. Here, I'll write this f of d of y equal to q of x. Now I'll rewrite this f of d means what? D power n plus p1 into d power n minus 1 plus p2 into d power n minus 2, and so on, that some pn. Now this is an equation. We'll write that equation in the factorization method, that is d minus alpha 1, d minus alpha 2, and so on, that d minus alpha n equal to 0. Now when I find out the particular integral will be 1 by f of d of q of x. Now what I write, 1 by f of d means d minus alpha 1, d minus alpha 2, and so on, that d minus alpha n into q of x. So to solve this expression, I'll solve for the only one case, that is that d minus alpha case. Let us write 1 by d minus alpha 1 into q of x equal to some I consider g. Now by the cross multiplication, this equation will be converted as g into d minus alpha into g. Let us write this as alpha equal to q of x. Now this is an equation of dg by dx minus alpha into g equal to q of x, where alpha is a constant, that we know that because of the root of the above equation. Now to solve this equation, now we'll write in this case the equation is dg by dx minus alpha into dg. This is a q of x. So this equation is called a linear differential equation of first order. Linear differential equation of first order. Equation of first order. Now we have a procedure to solve this differential equation, that is that we'll follow the integration factor, that is e power integration into alpha into dx, that is an e power alpha x. So minus is there, we'll write the minus here. So this is e power minus alpha x. Now what we have, this the general solution will be equal to g into integration factor equal to integration of q of x into integration factor into dx. Now I'll write this is the g into e power minus alpha x equal to, this is e power minus alpha x into q of x dx. Now I shift this e power minus alpha x into the right hand side, and then what we get, g equal to e power alpha x into e power minus alpha x q of x dx. Now this is the g equal to. Now what we have the g equal to 1 by d minus alpha into q of x equal to g, that is equal to what we have, e power alpha x is that e power minus alpha x into q of x into dx. Now whether the q of x is the following 5 special cases or not, we have to use this method. This is the more important case. The more important means, so whenever that q of x is not belongs to the form like e power x, sin x, cos x or x power m, or the combination of above one, e power x into v of x or x power m into v of x, then we can use this method. Let us write for the two cases, d minus alpha 1 or d minus alpha into d minus beta into q of x. Now I rewrite this is the d minus beta into 1 by d minus alpha into q of x. That is already we know that we can write as this one. So 1 by d minus beta into e power alpha x integration e power minus alpha x into q of x dx. Again we apply the same procedure like this. What we'll write, 1 by d minus beta we can rewrite as, we'll write this is as e power beta x integration of e power minus beta x into this term e power alpha x into integration of e power minus alpha x q of x dx into dx. Now this is the value. Okay. Now here this is the final equation of this one. But similarly we'll write one more equation here for your reference. 1 by d minus beta, d plus alpha into q of x. That is e power minus alpha x integration of e power alpha x q of x dx. The same way we'll write for the n roots, the previously what we have here. See this case, we'll write this is. So we'll go with the previous two cases case, or we can write in the partial fraction, use partial fractions and evaluate this one and apply the same method. So we'll write the partial fractions, what we'll write, a by d minus alpha 1 plus b by d minus alpha 2 and so on, that some a1, we'll write a2, some an by d minus alpha n into q of x. Then apply this, what are the method we have? So apply this method for d minus alpha into something. So we'll apply for this method for the previous case, that for the nth case. But we have some other, now we'll solve one problem for this case. Then after we'll solve for the special cases, we'll move to the special cases. Now we'll write one problem on this, then you can understand what is it. Now we'll write one problem here. The problem is d square minus 5d plus 6 of y equal to x into e power 4x. So this is a method, actually this is an x power m into v of x method, but we don't know till now what is the method of x power m into v of x. So let us follow the previous method. Now we'll write this is the solution of this. The complementary function will write, the given equation will write as d square minus 5d plus 6 of y equal to x into e power 4x. Let us consider this in equation 1. Now we'll write the auxiliary equation. The auxiliary equation will be f of m equal to 0, that I can write as f of m equal to m square minus 5d plus 5m plus 6 equal to 0. So minus 2 into minus 3, that is I will write m of minus 2 into m of m minus 3 equal to 0. Now that is m equal to roots are 2 comma 3. Now therefore the complementary function will be c1 e power 2x plus c2 e power 3x. Now this is the solution of the complementary function. Let us write the particular integral. The particular integral will be 1 by f of d of q of x. Now the q of x is what? 1 by f of d is a d minus 2 into, I'll write d minus 3, because we write here m minus 2 into m minus 3 with the help of the same notation. We can write as the d minus 2 into d minus 3 into x into e power 4x. Now we'll apply this formula, that is 1 by d minus alpha into q of x. We'll apply this notation for this, e power minus alpha x into e power alpha x q of x dx. So we'll apply this for this one. We'll write this is as 1 by d minus 2 into 1 by d minus 3 into x into e power 4x. So this I can write as 1 by d minus 2 as it is because we apply the latter. First we'll finish this part, then we'll apply the latter. Now d minus alpha place we have 3 is there, e power 3x integration e power minus 3x into x into e power 4x into dx. Now what we'll write, this is e power 4x and e power minus 3x is e power x, 1 by d minus 2 into e power 3x into integration of e power x into e power x into dx. Now we have to use that UV method of integration by parts. We'll solve this. Now this solution will be x into e power x minus e power x. Now I'll take the e power x is the common, that is d minus 2 times of e power 4x of x minus 1. Now this is that one more q of x, we have to solve this. Now I'll split into these cases. Now what I get, this is 1 by d minus 2 of x into e power 4x minus 1 by d minus 2 into e power 4x. Now already we are solved this 1 by d minus 2 is that integration e power 2x integration of e power minus 2x x into e power 4x minus e power 2x integration of e power minus 2x e power 4x dx. So we'll apply the theorem for this, the UV rule, x into e power 2x minus e power 2x of e power 2x into dx. We'll take the common of e power 2x here. Now this is x into e power 2x by 2 minus the derivation of x will be 1 and the integration of e power 2x, that's 2 times will be 4 and minus e power 2x by 2. Now I'll write the solution of this, e power 2x is a common here. So again I take that e power 2x is a common there. This is e power 4x. So here I'll take that common of e power 2x and e power 2x and e power 2x. Now e power 4x, now this is the 4 also I'll take the common here. Now this is 2x and this is minus 1, this is minus 2. So therefore finally what we get, e power 4x of 2x minus 3 is a solution of the particular integral. But as we know that the general solution of this differential equation 1 will be the complementary function plus pi, the particular integral. That is, I'll write c1 e power 2x plus c3 e power 2x plus e power 4x of 2x minus 3 is a solution. This is the final solution. Now see how much steps is required to solve this problem. Because of that reason, we are introducing some special cases. The special cases already I mentioned, the special cases is, these are the special cases. Now the q of x will be the following functions. How we are going to solve now, we'll see one by one. Now we'll dealing with the e power x. So what is the procedure for e power x? Now we'll write the case 1. I'll call the case 1. If f of d of y equal to q of x, where q of x will be equal to e power ax. Now this is our first case, e power x. In this case again we have the two cases will be there. What are the two cases we'll discuss? The two cases, let us write first case. Now case A, that is that f of pi will be, we can rewrite as 1 by f of d of q of x. So that is 1 by f of d of e power ax. Now directly put d equal to a in f of d, then f of a will be not equal to 0, f of a not equal to 0, then we have to use this method. Otherwise, if it is equal to 0, we have another case. We'll rewrite the another case. Therefore, this is the particular integral will be then 1 by f of a into e power ax. So this is a final solution. There is no doubt on this. So this is a final solution. When it is not equal to 0, but the case 2, the case B, we can write that f of a is equal to 0. Let us consider. So first case will be not equal to 0. The second case will be the equal to 0. If it is equal to 0, this term will be undetermined. That 1 by 0 is undetermined. So we cannot find out the solution. In such cases, how we are going to solve this problem? Now let us write the particular integral will be 1 by f of d into e power ax. So when I substitute the d equal to a, this is equal to 0. Now this is not valid. Now we rewrite this f of d as, so we write f of d as pi of d into d minus a whole power k. Now here I am writing this a and this a will be the equal. Then only this a and this is the d minus a, means is one of the root of the complementary function. Now in such cases, this will be the same, then this will be get. So easy to identify which case will be existed for the given problem. Simply the roots of this differential equation, means the roots of the complementary function. When I find out that is a m equal to some root, that m root will be is matching with this a. Now this a, then we'll get the second case. If all the roots are not matched with this a, then we get the first case. So that is also the easy identification for the problem. Now we'll rewrite this function as this one. Therefore, the particular integral will be 1 by pi of d minus a whole power k. And one more case here, pi of a is not equal to 0 when d equal to a. When I substitute that d equal to a in this pi of d, this will be not equal to 0, then only this is valid. So therefore, into e power ax, therefore the solution will be, therefore the particular integral rewrite here again, 1 by pi of d and d minus a whole power k into e power 2 ax. So therefore this become 1 by pi of a, will put d equal to a in this equation, that is x power k by k factorial into e power ax. Now this is the particular integral. When I substitute the d equal to a in this given f of d, then it is 0, then this is the complementary particular integral. If not equal to 0, this is the particular integral. Now we'll see the two problems on this, one problem on the first case and the other problem on the second case. Now see, the identification of this problem will based on that a only. That a will be, this is the a. So here the a will be, for example, this is the a, is matched with the root of an equation of f of d. The root of f of d will be that if that at least one root will be matching with this a, we'll get the second case. If not matching with this a, then we'll get the first case. So that also is one of the easy method to identify which case we'll get in this case. Now we'll write the one problem on this. The first problem, solve the differential equation, solve the dE and d square plus 4d plus 3 of y equal to e power 2x. So this is a given differential equation. I'll solve this differential equation. Will be the differential equation is we'll find out the complementary function first, then after the complementary function will be solution. Given differential equation is d square plus 4d plus 3 of y equal to e power 2x. Let us consider that one. So this a equal to 2 here in the right hand side of e power x equal to e power 2x, that is that a equal to 2. Now here I'll write the auxiliary equation. The first step as it is, we have to follow f of m equal to 0, that is f of m equal to m square plus 4m plus 3 equal to 0. I'll write m equal to roots, this is minus 1 into minus 3, Now therefore I'll get m of m plus 1 and m plus 3 equal to 3 plus 1 is a 4. The factorization method, that is m equal to minus 1 comma minus 3. Therefore the complementary function is c1 e power minus x plus c2 e power minus 3x. See, we'll notify first of all the roots are matching with the a value or not. We'll notify this. Sir, what are the roots here? This is the roots minus 1 and minus 3. But that a equal to 2 here. I'll write the a equal to 2 here. This a equal to is not matched with this, that the roots. Therefore, when I substitute the d equal to a, in this f of d, it never get the 0. So therefore, we'll go for the case 1. So now the particular integral will be what? The particular integral will be 1 by f of d of e power 2x, that is 1 by d square plus 4d plus 3 of e power 2x. So this 2 is not matched with this roots, therefore it is not 0, that f of d. Put d equal to a, that is equal to 2 in f of d. Therefore the value is 4 2 whole square plus 4 into 2 plus 3, 8 6 plus 8 plus 8, 16 plus 3, that is 8 and 4 plus 3, that is 1 by 15 of e power 2x. This is e power 2x. So therefore the particular integral will be, this is the particular integral. Therefore the general solution of this problem will be CF plus PF. What is the CF? Already we know this. C1 e power minus x plus C2 e power minus 3x plus 1 by 15 of e power 2x. See how much steps we reduces by knowing the special cases. So let us see the same problem we can solve by the previous generalized method. See that how much difficulty is there. Because of that reason, they are generated some special cases to evaluate easily the problems. Now we'll see one more problem for the case 2. The case 2 problem. Solve d cube minus 5d square plus 8d minus 4 of y equal to e power 2x. Now e power 2x. Now here again we'll solve this problem by the normal method solution. Given differential equation is d cube minus 5d square 8d minus 4 of y equal to e power 2x. Okay, now we'll find out the auxiliary equation, that is f of m equal to 0, that is f of m equal to m cube minus 5m square plus 8m minus 4 equal to 0. To solve this equation, we require that we'll go with the trial and error method. We'll substitute the 1, we'll never get the solution. We'll get the solution or not, we have to verify whether it is satisfied or not, we have to verify that. Put m equal to 1 here, 1 minus 5 plus 8 minus 4. Minus 5 minus 4, 9, and plus 1 and 8 will be 9. Therefore, it is satisfied. So, therefore, when I solve this equation, this is m minus 1 into m minus 2 into m minus 2 will get equal to 0. Therefore, the roots will be repeated here, 1 comma 2 comma 2. Therefore, the complementary function will be c1 e power x plus c2 plus c3x of e power 2x. So, here one more thing you have to observe here. The observation is this 2 is matching with this 2 here. So, the right hand side q of x term is the e power x. Actually, we are given that e power x is that e power 2x. That 2 will be matched with the roots. Therefore, we'll get the second case. In the case, the particular integral will be 1 by f of d e power 2x. That f of d, 1 by f of d, I write as that d cube minus 5d square plus 8d minus 4 into e power 2x. When I substitute the 2 equal to in this equation, this becomes 0 because already it is proved. This is the 2 is the one of the root of this auxiliary equation. In such cases, write f of d as d minus 1 into d minus 2 whole square. So same story, we'll copy it from here, m minus 1 into m minus 2 whole square. Now when I substitute that, let us write this is equal to pi of d into d minus a whole power k, where pi of d will be d minus 1 and uh, d minus a whole power k will be is d minus 2 whole square. Now k equal to 2 and a equal to 2, then when I substitute that, this case the pi of a is not equal to 0. That means when I put the 2, that is 2 minus 1 is not equal to 0. Therefore, we'll rewrite this d minus 1 d minus 2 whole square into e power 2x. So therefore that is 1 by 2 minus 1. So the formula is x power k by k factor, that is x square by 2 factorial into e power 2x. So therefore x square by e power 2x by 2 is the final answer. Here I am using 1 by pi of d into d minus a whole power k e power 2 e power x will be x power k by k factorial into e power 2x by pi of a. I am using the concept of this one, then based on that I will explain this one. Now therefore the general solution will be equal to CF plus PI, that is equal to C1 e power x plus C2 plus C3x of e power 2x plus x square by e power 2x by 2. Now this is the final solution of the problem. This is a general solution. Now already I explained so many times, the general solution means the number of arbitrary constants should be equal to the order of the differential equation. The order of the differential equation will be 3 here. The number of arbitrary constants are C1, C2, C3 are the number of arbitrary constants. Now these are some models, and I'll write some questions for your reference. So I'll write some problems for your reference. These problems will be d cube minus 6d square plus 11d minus 6 of y equal to e power minus 2x plus e power minus 3x. And the second one, d square minus 3d plus 2 of y equal to cos hx. The cos hx, I'll give the hint for you. Cos hx is the e power x plus e power minus x by 2. So whenever they are provided the cos hx, don't use the previous method. So that is applicable, but the integration of cos hx, maybe the difficulty is there, you can go with this one, e power x plus e power minus x by 2. Now the third one, d plus 2 into d minus 1 whole square of y equal to e power minus 2x plus sin hx. The sin hx, again I'll give the clue for you. Sin hx is e power x plus, e power minus x by 2. Now the fourth one, d cube minus 4d plus 3 of y equal to 4 into e power 3x. These are the 4 models for the special case 1. The special case 1, I repeated once again, f of d of y equal to q of x, where the q of x is the e power x. So any right hand side term will be the q of x will be in terms of e power x. We have to use this method. So this is the method, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.